Students, today you have to discuss torque acting on an electric dipole placed in a uniform electric field. Here the word you have to know it, torque. This torque word that you know from the class 11, and here another is the uniform electric field. Uniform electric field means actually at every point that you will get the electric field strength will be the same. So that uniform electric field will be represented by straight and parallel lines. These are the uniform electric field. Clear? And the electric dipole consisting of minus q and plus q charge. This is placed in an uniform electric field. It is placed in the uniform electric field. And we will be finding the torque acting. The torque will be acting on this dipole. Students, before that I would like to tell you that whenever the charge particle is kept in the electric field, it experiences a force. It experiences a force by the formula F equal to E into Q. This is the force acting on the charge particle placed in the electric field. Force F is the force acting on the charge particle, E is the electric field strength, and Q is the magnitude of the charge. So here the dipole is placed here. Dipole means actually plus q charge and minus q charge. Whenever the plus q charge is here, the force will be acting on this plus q charge, and that direction of the force will be in the direction of the electric field. Plus q, it will be directed along. So that force equal to q into E. Q into E is the force acting on the plus q charge, and it is directed along the direction of the electric field. Another charge minus q is placed in the electric field, and it will be directed opposite to that of the electric field. So that in this case you are getting the force that is equal to minus QE. So here the dipole, for net force, what is the net force acting on the dipole? In one case it is QE, in another case it is minus QE. The net force equal to the net force acting on the dipole equal to QE minus QE, and this is equal to 0. So in this case the net linear force acting on the dipole will be 0. So what happens to the dipole when it is kept in the electric field? So what will happen? The torque will acting on this dipole. So what is the torque? The torque word you must be knowing. Torque is the rotational force acting on the body. So here what type of rotational forces will be acting on that dipole? The important thing is that you know the torque is the either force multiplied with the perpendicular distance from the axis of rotation. But here in this case, that one force is acting along this direction, another force is acting along this opposite direction. Both the forces are equal in magnitude, opposite in directed, and they are not acting along the same line of action. For example, if the object is here, the force is acting along this direction, another force is acting along this direction. If both will be equal in magnitude, oppositely directed, but acting along the same line of action, the net force acting on it will be the 0, and the net torque also will be 0, because both are acting along the same line of action. But here both the forces are not acting along the same line of action. Q is acting along this way and minus Q is acting along this way. This is the line of action of this force and this is the line of action of this force. Both the forces are not acting along the same line of action, so hence the torque will act on it. That you can tell it as the couple. That is what will be the torque acting on the dipole? So torque acting on the dipole will be equal to the moment of the couple. The couple will be produced and the dipole will start moving in the uniform electric field. So what is the moment of couple? Moment of couple equal to magnitude of either force, any of the force, multiplied with the perpendicular distance between the two forces. So what is the perpendicular distance between two forces? One force is acting along this way, another force is acting along this way. So AC will be the perpendicular distance. AC will be the perpendicular distance. Hence, torque equal to magnitude of either force, because both the forces are equal in magnitude, multiplied with the perpendicular distance between the two forces. So here torque equal to magnitude of either force, that is the QE, multiplied with perpendicular distance, that is SE. So it will be equal to QE into 2L sine theta. What is the SE? Because this theta is the angle made by the dipole with the direction of the electric field. So what will be the according to Pythagoras theorem, you can, or according to the sine formula, you can use sine theta equal to P upon H, that is AC upon length of the dipole 2L. So sine theta equals, you are writing sine theta equal to AC upon 2L. And what will be the AC? AC equal to 2L sine theta. So here in this case, you are applying QE multiplied with 2L sine theta. So this is equal to Q and 2L. It is collected here and left out is the E sine theta. What is the Q into 2L? Q into 2L is the dipole moment, because dipole moment, you know the definitions of dipole moment. Either charge multiplied with the separation between the two charges or length of the dipole, that is Q into 2L. So Q into 2L multiplied with E into sine theta, that is equal to Q into 2L equal to PE sine theta. In vector representation, if you represent it in vector form it will be equal to torque equal to tau equal to P vector cross E vector. It is clear the P vector and E vector. If P vector and E vector both will be lying on the line, the torque will be perpendicular to the P vector and E vector. By using this formula, we can write, suppose theta. You just mind it, actually the direction of dipole moment. Direction of the dipole moment is always directed from negative to positive direction, like that. This is the angle between theta, because electric field intensity is along this way and dipole moment is along this way. So this is the angle theta. If theta equal to 0 degree, so what will happen? If theta equal to 0 degree, according to this formula, sine theta, sine 0 will be the 0 and the torque acting on the dipole will be 0. Similarly, if theta equal to 180 degree, the dipole torque will be 0, because sine 180 also 0. If theta will be 90 degree, that means torque will be equal to sine theta equal to maximum, that is equal to 1, and the torque acting on the dipole will be PE maximum. So it is clear, one thing I would like to tell you, that the torque will be acting on the dipole whenever it is kept in the uniform electric field. The question may be arising here, if the dipole is kept in the non-uniform electric field, what will happen? Non-uniform electric field means that the amount is different. All the different points having the different electric field intensities. If the intensities will be different, so automatically the forces will be different. So this force may be greater than this force. So we can get the net effective force acting on the dipole. If it is kept in the non-uniform electric field, the net force acting on the dipole, you will find the net force acting on the dipole. In case of the uniform electric field, the net force will be 0, but the torque act on the dipole. So for that also I would like to tell you some example. Whenever the charged cum is kept near the small pieces of paper, what will happen? The small pieces of paper will be directed towards the cum. Why? Because the charged cum produces the electric field which is non-uniform electric field, and the small pieces of paper immediately by the method of induction, that will by method of polarization also we can tell that small pieces of paper will be behaving like a dipole, and that is kept in the non-uniform electric field. The dipole, that small pieces of paper will be experienced by both linear forces and by the torque. Due to this reason, the small pieces of paper will be rotating and will be moving towards the cum. So both the net electric field, net force and net torque will be acting on that small pieces of paper. In this manner, the small pieces of paper will be directed towards the charged cum. So this is the torque acting on the dipole placed in the uniform field. I would like you to give some assignment on basis of the dipole and the torque acting on the dipole placed in the electric field. Thank you.